Hello everyone, myself Joseph again, assistant professor Assam Downtown University. Today I will discuss one topic, that is methods to determine the endpoint of potentiometric titration. Ultimately, we are going to discuss that is endpoint determination of potentiometric titration. Some different methods are there. We'll see one by one. What is potentiometry? So, potentiometry is the field of electro analytical chemistry in which the potential is measured under the conditions of no current flow or zero current flow, so as not to disturb the equilibrium at the sample membrane interface. And the measured potential can be used to determine the analytical quantity of interest, generally the concentration of some component of the analyte solution. A typical cell for potentiometric analysis can be represented as a reference electrode, then salt bridge, analyte solution, and indicator electrode. The potentiometric titration involves measurement of the potential of a suitable indicator electrode as a function of the volume of titrant added. You can say that potentiometric titration involves changes in the cell electromagnetic force and brought about by the addition of a titrate of an accurately known concentration to the test solution. And the equivalence point of the titration is detected by rapid changes in electromagnetic force. The equivalence point may be calculated or it can be detected by the inflection point of the titration curve. And inflection point means it is a point that corresponds to the maximum rate of change of the cell EMF per unit volume of titrant added. So here you can see this is the potentiometer, instrument potentiometer, and the graph represents the titration with sodium hydroxide in presence of carbon dioxide. This is the potentiometric titration. The schematic representation of an automatic potentiometric titrator devised by Lingan in 1948. Here we can see this is the apparatus for potentiometric titration. A reference electrode is there, indicator electrode, and a burette. This is the titration vessel and a magnetic star. So some potentiometric titration, we are going to discuss about methods of the endpoint location, how to determine the method of potentiometric titration. So first one, we have a graphical method, an analytical or derivative method. Then think of Treadwell method, direct titration to the equivalence point, and a Grant's procedure. So the first one we are going to see is graphical method. So the simplest approach of determining the endpoint is the visual estimation of the midpoint in the steeply rising portion of the titration curve. Here you can see this point of infection. So point of infection, that will be the endpoint volume. Here you can see the line from the point of inflection intersecting the volume axis and perpendicular to it, so we can determine the endpoint from there. So in the left y-axis you can see the pH, and volume of titrant in x-axis. After that we have analytical or derivative method, the second one. So it consists of plotting the first derivative curve, that is delta E by delta V against V. So or second derivative curve, delta square E, delta E square by delta V square against V. So the first derivative curve gives a maximum at the point of inflection of titration curve, that is at the end point, and the second derivative curve is zero at the point where the slope of delta E by delta V curve is maximum. Here you can see this is a first derivative plot for a potentiometric titration curve. This is a first derivative curve. This is the second derivative curve we are getting, as you can see. And ultimately, in case of normal titration curve, we are getting the endpoint here like this, volume of titrant. Here you can see the first graph. and in first derivative curve we are getting like this the endpoint, and for the second derivative curve we are getting this type of endpoint. Thank you.